problem's actually quite nice. Okay, so we have 25 cells in a 5 by 5 grid of squares, and it's filled with zeros, ones, and twos in such a way that the numbers written in neighboring cells are differ from their neighbor by a diff by 1. And so yeah, and this is quite a famous configuration in that you know that this is going to end up being evens. Like, let's say, assume that something here is even, then that means that these, since these differ by 1, these have to be odd, and then these are even. That has to be odd, even, odd, even, odd, and so on. And as long as you have that, then you'll mostly be fine. So here, I just chose the top left corner to be even. That's not necessarily always true. So we break it down to 2 cases. Case 1 is that's a 1 over there, and case 2 is that we have an even in here. And so if we have a 1 there, then all of, oh no, we have a bunch of odds, and then the other ones just have to differ from 1 by 1. So that means they can be 0 or 2. And that's awfully convenient, because as long as each of these are either 0 or 2, it works. And there's 12 of these. So that means that there's 2 to the 12th possibilities over here. And over here, almost the same thing happens, except we put it like that. And because the corners are held by the evens, that means that there's going to be 13 evens, and each of the evens can be either a 0 or a 2. So there's 2 to the 13th possible setups of the kind on the right. And that means that in total, the total number of arrangements is 2 to the 12th plus 2 to the 13th, which equals 3 times 2 to the 12th, which equals 4,096 times 3, which is 8, 28, 12,228. This problem's quite nice.